Okay, let's make a deterministic finite automaton for this language, which is the set of all binary strings W, where W contains 0, 1, 0, 1 as a substring. So 0, 1, 0, 1 has to appear contiguously in the string, and otherwise it can contain anything. The way to approach a problem like this, in any kind of substringy problem, I made myself laugh there, is to focus on the condition to be in the language and then add transitions otherwise. So let's focus on the string 0, 1, 0, 1 by itself. So I want to recognize exactly 0, 1, 0, 1. So if we do that, we can just have a bunch of transitions in a row that involve just reading a 0, then a 1, then a 0, then a 1. And then that goes clearly to a final state. And so that is a DFA without the dead state transitions for exactly the string 0, 1, 0, 1. Well, let's think about what this means. This means that we haven't read anything of the 0, 1, 0, 1 yet. We have read exactly the 0 at the front. Here, if we're here, that means we've read 0, 1 so far. Here, that means 0, 1, 0 we've read so far. And here, we've finally got the substring that we want. It doesn't matter what we read after the fact. No matter what we read, we're going to still be in that language. And so therefore, we should have a self loop with 0 and 1 on it. Now let's think about where all the other transitions go. So if we read a 1 from this state, then that doesn't progress us along the 0, 1, 0, 1 route. And so therefore, we need to stay here because we're not progressing. Let's think about where 0 would go here. Well, if we read a 0 from this guy, then that means that we still have read only the 0 part of the 0, 1, 0, 1, namely the front 0. And so therefore, this is going to be a self loop here. So let's think about where 1 goes right here. That means that we have read a 0, either from here or from here, a 1, and then another 1. Well, if we do that, that has messed up everything that we have done so far. And so therefore, we need to go all the way back to the beginning because it screwed everything up. Technical term. So we need to have the 1 go back over here. And then if we do a 0 from here, again, that screws everything up because if we read a 0 from here, that's akin to saying we have read 0, 1, 0, 0, and maybe other stuff before. But the substring is 0, 1, 0, 0, and that's clearly not the substring that we want. And so therefore we need to have this 0 transition go all the way back to not the beginning though. That is a fool's errand, because if we go all the way back to the beginning, then that means the 0 we just read, if we did that, would go all the way back here. But if we have, let's say, 0, 1, 0, 0, 1, 0, 1, then this should be accepted because it contains 0, 1, 0, 1 right here. But if we did this, that's 0, 1, 0, 0, 1, 0, 1, and it's not accepted. So we actually need this transition to go instead back to here. It kind of screwed everything up, but not quite. And so therefore, it needs to go back to there. And so this is a DFA for all binary strings that contain 0, 1, 0, 1 as a substring.